Okay, so a fair number of you are here. Hopefully the rest of you, let's see, how many of you showed up? 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14. So yeah, just about 2 of you missing. Hopefully they get my email and show up. So welcome to the class. Hopefully you're all here for calculus. So this is the first time I've run like a fully online class, but I think it's going to go well. It's going to be a little bit different than maybe some of your other classes have been, at least in math. Because the way it's going to be structured here is essentially that instead of me lecturing the entire time, because I did some of that in the fall when everything had to go online, and I think kids got bored with that really easily. So what I've done is I've put all the lectures into just videos you can watch, which I recommend you do ahead of time. And then we're going to spend most of our time in class actually just solving problems and figuring out what things we don't understand and how we can understand them. So we call that kind of a flipped class model. So that's where I kind of want you to be thinking is you want to be doing some work ahead of class, like watching some videos, maybe reading the book, and then when you come to class, we're going to be trying to actually work through problems and make sure we understand everything. So that's kind of the idea of how things are going to work. So maybe we could just go around and have everybody introduce ourselves. I think our class is small enough that we could probably get to know each other a little bit. So let's see, we'll just go in like alphabetical order. How about Cameron? You want to go first?
Yeah. Hi, my name's Cameron. I'm gonna be a junior. Is that it?
Thank you, Cameron. Parker Courts?
And my name's Parker. I'm from North Carolina. And I'm about to be a freshman.
Cool. How about Celine Boise?
Hi, my name is Celine Boise. I'm a rising sophomore and I'm in Guatemala.
Thank you. How about Chris? Wow. How do you say your last name?
Warhaftig. I'm from New York.
Cool. Who else we got? Christina?
Hi, I'm Christina. I'm going to be a rising junior, and I'm from Toronto, Canada, but I'm currently at Wake Forest for training.
Okay. What are you training in?
Basketball.
Cool. How about Connor?
Hey, I'm Connor. I'm from Fort Worth, Texas. I'm about to be a sophomore.
Great. And then we got, let's see, Courtney.
Hi, I'm Courtney. I will be a sophomore, and I'm from North Carolina.
Thank you. How about Ella?
My name's Ella, and I'm from Houston.
Cool, thank you. We have Leanne.
Hi, I'm Leanne. I'm from Louisville, Kentucky, and I'm going to be a freshman.
Yeah, how about Mary?
Hi, I'm Mary Martha. I'm going to be a sophomore, and I'm from Georgia.
Thank you. Got Olivia?
Hi, I'm Olivia. I'm from Colorado, and I'm going to be a senior.
Colorado, that's where I'm from. Cool. Parrish?
Hi, I'm Parrish. I'm a rising senior. I'm in North Carolina right now.
Cool. Pedro?
Hi, I'm Pedro. I'm going to be a freshman in the fall. I'm from Connecticut.
Great, thank you. Sam?
Hi, my name is Sam. I am also a rising senior, and I'm from Los Angeles.
Great. Tarek?
Hey, I'm Tariq, and I'm from San Francisco, and I'm about to be a freshman.
Great. We got Sam. Did we already do Sam?
Yeah.
Will?
Hi, I'm Will. I'm from North Carolina, and I'll be a rising sophomore.
Thank you. And then Yu Yao, can you introduce yourself?
Yeah, sure. Hi, everyone. I'm Yao, and I'm the second year graduate student in Math and Stats program. And I will be your guys' TA for Math 101 this semester. It's my first time to TA this class. Like previously, I was the TA for linear models and some other stats class. So feel free to ask me also some stats question. Yeah, I will be able to help them as well.
Great, thank you. So yeah, she will be helping us a little bit in class, and she will also be holding like study and homework help sessions that you guys can go to, because there is quite a bit of homework in the class. But we also have a lot of time where you can get help for it. So, okay, so yeah, nice to get to know you a tiny bit. Let's start talking about kind of how the course is structured. So I'm going to share my screen and pull up the syllabus. Let's do this one. Okay, so the first thing in this class is you want to be able to get to our Canvas homepage. Let's see if I can make it look like yours would look. Where's View as Student? Yeah, so if you go to our Canvas homepage, this is where kind of the whole class will revolve around. And that does have the correct Zoom link there. I think some of the ones in the actual day pages are wrong, which is why a couple people had trouble. So yeah, let's first take a look at the syllabus. Now let's just see if I can open it here. Okay, so as you've probably noticed, this class meets every single day of the week: Monday, Tuesday, Wednesday, Thursday, Friday, and occasionally Saturdays, 2 Saturdays. But these Monday and Thursday extra classes, I probably won't hold them at all on Mondays, but I will just stick around on Thursdays if you want extra help. But they're completely optional. So that's sort of getting replaced with the time where you watch videos, okay? Yeah, there are these 2 Saturdays, and our exam will be on August 11th, so make sure you have that on your calendar. I'll talk about my office hours in a second. I still have to put them in here. I just decided on them yesterday. The things you need for this class are the textbook, WebAssign, and a calculator. Okay. And the way the course grading is going to work is it's split into 4 things. I decided to not require attendance. I felt that might have been a bit too much in an online class. And yeah, somebody's asking whether there's an online version of the textbook. So I believe, I've never actually gone through the process myself, but I believe when you sign up for WebAssign and you actually end up purchasing it, there's an option that lets you purchase a copy of the ebook with WebAssign. So if you didn't buy a hard copy, you can get it that way. Yeah, so your grade's going to depend on 4 things. Basically, there's homework and exams. The homework consists of WebAssign, and then each week there will also be short handwritten assignments. Some of them will actually just be like WebAssign questions that I ask you to actually write out full solutions. Because when you do the online homework, it's good to know whether you can get the right answer, but it doesn't tell me whether you're, doing all the steps correctly, and also whether you know how to like write mathematically, like present it so somebody else can understand it. So there's going to be our online WebAssign homework and worksheets. And let's see. So we could just go look at WebAssign. So to get started with WebAssign, that's going to be one of your first goals. So what you'll do is, the easiest way to do anything is probably just go to the weekly plans down here. Click week 1. And this will bring you to our module page, which basically contains everything. And if you click Getting Started at the top, it has these 2 things I'd like you to do by the end of the day tomorrow. They're both very short. Yeah, but you can read through this. It tells you a little bit about WebAssign. Let's see, what are the important things to hit here? So the first thing is you should always access the WebAssign through Canvas, because that links your grades over to Canvas. So you might click like one of these links, it'll bring up something like this. Then you click the button, it opens a new tab, and it should take you to WebAssign. And since I've already signed in with this test student, it brings me directly to the homework. But when the first time you do it, it'll ask you to sign up for a free account. So you'll have to sign up for a free account. And then if you decide to stay in the class, you'll eventually have to purchase it. And you'll see at the top here, it has, you can purchase access. Okay, so that's sort of WebAssign. And those homeworks can be due just about every night. So it's pretty sort of intense homework. But that's sort of the most important learning tool in the class. Okay, so that's the homework. Let's see. Let's go back to the syllabus. Oh yeah, the other thing was the assignments. So yeah, the 20% of your grade is worth for worksheets and assignments, and those are, you can find them in the same place. So like if you go to week 1, your first worksheet is due on Thursday. So you'll see under each day it kind of has, well, maybe let's look at one of these. So each day, the way this is laid out is it kind of has a list of things I hope you consider doing. So I kind of tell you in blue like what I hope you learn from this section. And then here are kind of the things to do. So like for today's class, I would like you to read through the syllabus and the schedule. And if you have time, read through section 1.1 of the textbook. There's some videos you can watch. And here's the Zoom class link. And I think these are the ones that have the wrong link. I have to go change all these to the one we're using now. And then, yeah, here. So in here, you can either find the links to the worksheets in these checklists, or you can find them just under the days. Like, so I think on the day it's due, this will be summary sheet 1. Oops, I didn't click on it. And this should have a link to the PDF. And so for the first 2 weeks, I have these little worksheets that I'd like you to work through, but I'm not asking you to turn all of the problems in. I'm just asking you to turn like 2 or 3 in. So it's not a whole lot of work if you really just want to do the minimum. But so these ones in blue that say turn in, those are what I expect you to have. Like you just write them down on a piece of paper, or you can type them or do them on a tablet if you want as well. So here I think there's 4 of them over the next 3 days. You just write them out on a piece of paper, you scan them with either a cell phone or a scanner, and you upload them to this assignment page. So you would go under summary sheet 1. Whoops, that's the wrong thing. So you would go down to summary sheet 1, and you would submit the assignment by just uploading your PDF. Okay. All right, so any questions so far on the homework stuff? There's probably going to be things I forget to tell you, so please ask questions when they come up. And the rest of the grading stuff, at least, is pretty straightforward. It's just exams. We only have 2 exams. We'll have like one in the middle. I think it's 4 weeks through. If you want to figure that out, you can always look at the schedule. So here's what I have planned out. There's a chance it might not go exactly quite like this. We might have to change things up if we get behind or ahead or something. But you'll see our first exam is at the beginning of week 4. And this kind of tells you what we're doing each day, what things are due, which homeworks, which assignments are due. So this should be a quick and handy thing. Let's see. So that's, what else do I have to say something about? So we have, so you can look at how I'll be distributing the grades. They're pretty typical. But I do reserve the right to make it easier than this, but I'll never make it harder than this. Blah, blah, blah. You can read through this. I think I hit on, oh, I already see a typo in the syllabus. There's only one exam, and it's the one on the schedule. I have to update that. But yeah, I think I hit all the main points there. You can read through the rest yourselves. Okay, what else do we want to talk about? Yeah, oh yeah, office hours. So because there is so much like homework due every day, there's going to be a help session available to you every weekday. So, and those are these links in blue here. So if you want to, have question answered or get help with a homework problem, you can drop by these links during these times. So on Mondays and Tuesdays, we're going to have Yu Yao, our TA. She'll be available from 5 to 7 or 4 to 6, depending on the day. And then Wednesday, Thursdays, and Fridays, you can stop by between 7 and 8. It's just a Zoom session that you can drop by on. I do recommend setting aside certain times that you work on the homework. So these might be good at times if you're available then. But if you're really not and you still have questions, I can also meet other times sometimes. Just send me an email. Okay. Okay. So I think that's a lot of what I wanted to say. Do you guys have any questions about how the class will work? I'm sure there will be once we get started, but basically you do the homework and assignments, then we'll have an exam in the middle of the class and a final exam. Okay.
I have a question.
Yeah.
So will the exams be like open note? I saw you mention something about you can have your textbook, or I may be wrong. I don't know.
So yeah, my policy is I'm gonna let you use the textbook and your calculator.
Okay.
But I prefer nothing else.
Okay, thank you.
Any other questions?
So just to refresh on what you said, each night we're supposed to be doing, so we have a certain module in there or chapter in the textbook to do each night, and then once a week there's like a worksheet to do?
Yeah, so the easiest way to understand what you should be doing is either to look at the schedule or just look at the modules page here. There's kind of a checklist for each day if you're wondering what you should be doing on any given day. So if we look at tomorrow, let's look at Wednesday. So Wednesday, in an ideal world, you would maybe skim through the textbook or read it, depending on how familiar you are with it. Then watch at least these first two videos. The other big list of stuff is optional if you feel like you need more refresher. Then you would come to class, and you might start working on the worksheet, which isn't due Wednesday, but it'll be due Thursday, and start working on the homework.
So that's the day assigned, not day due.
Yeah, so there's stuff that's assigned, and then there's other stuff that was due from the previous day. So homework is usually assigned one day, and it's due by 11 p.m. the next day. So that's another thing that it reminds me of. All the due dates are 11 p.m. on the day that it says. So if it says it's due Thursday, it's due Thursday by 11 p.m. Okay. So yeah, here's, for Wednesday, you're supposed to start 1.2, 1.3, and 1.4. And the stuff from the previous day is due. So section 1.1 is due. So ideally you would get as much of 1.1 as you can done by the end of today. I think it's only 10 questions, but you also have these other 2 quick things to get done as well. They're very short, but Yeah. Okay. Any other questions?
Will the Math Center be doing like virtual tutoring, or do you know anything about that?
There may be I think it's a little bit up in the air, but there may be some availability for one-on-one sessions. But mostly they've given us time with the TA. These times I listed below, these are kind of like at the study sessions they would normally run.
Okay.
Okay. Yeah, I think we'll know more about the one-on-one sessions in a few days after everybody has their schedules pinned down. Okay. So were you more concerned about like one-on-one tutoring?
Yeah, I was just curious about it. I didn't really know like about the TAs until now, so I was just wondering if they were even doing virtual sessions.
Yeah, I mean, our TA is going to hold these on Mondays and Tuesdays nights, and I'll hold them Wednesday, Thursday, Fridays. So you have somebody available at least once a day, every day. But there may be other opportunities as well that I'll let you know of.
Okay, perfect.
Okay, so that's all I really want to talk about with the logistics of stuff. Maybe we can jump into a little actual math today. Let's see. So let me share another screen. Okay, I'm gonna turn my video off. So today's topic is we're basically trying to cover section 1.1 in the book, which is just a bunch of stuff about functions. So really these first 4 sections in the textbook are really what I would consider prerequisites. But I'm going ahead and doing them just so that everybody has at least a little time to catch up if you haven't used these things in a while. So let's just briefly talk about what a function is. I'm not going to go through it. You can watch some of the videos I posted if you want a little more. But I'll give you the definition. So when I think of a function, I think of something that relates to things but only goes in one direction. So one notation you'll sometimes see, we're not going to use this in this class really, but it's good to at least have seen it once, is, if I have a function that might be called f, it has what's called a domain and a codomain. So the domain is the thing that comes first, and the codomain is the thing that comes second. And the codomain is a little different than the range, which we'll talk about in a second. And what it does is it takes things in your domain, so it's always between 2 sets. And remember, you don't really have to care too much what a set is. A set is just like a collection of things. For us, it'll be a collection of numbers, of real numbers, like an interval or something. And so what a function really is an assignment rule. It tells you, what do I do with things in the domain? Okay. And that assignment rule has to tell you for every element, so any number in your domain, it does something to it. So it takes something in the domain and it spits out something in the codomain. And it only can spit out a single thing. And that's what makes it like this one-directional thing, right? I can't have one input and 2 outputs, right? a single, and the output we always, or at least one way of writing it is f of whatever we put in. So let's see. If I want to make this a little better, we would say maybe we have the element A in the domain. And then we would have, so if you plug in A to F, you get F of A out, right? So you have input and you have output. That's the main thing that you really have to take away for this. And this will be in B, the codomain. I should really write this in black. That's not. Okay, so, I mean, we're not usually going to think about it this abstract, but this is really what it is. It's just some rule that tells you for everything in your domain, something in the codomain. For us, it'll usually be an equation that tells us how we get from the input to the output. And, you know, just some comments. A is the input. F of A is the output. A is called the domain. And then the one thing we haven't hit on is the range. So we're usually going to not think about the codomain. You can kind of forget about that. We're going to more, we're going to talk about the range more often. So the range is different than the codomain. It's usually smaller. The set of all right, so everything that it can actually be output by a function is called the range. So if you wanted to write that in like set notation, it's the set of all f of a for an input in A. Right, it's all the things that can come out of the function. It's the collection of all of those. That's called the range. Okay, so let's just look at some of the functions you've typically probably seen before in the past. Just some easy examples. So, you know, the one function everybody knows is f of x equals x squared, right? But let's be very specific. Like, this is a function from where to where? What do you guys think? What type of stuff does it take in? So can anybody give me a valid input? What's a valid thing to plug into this function?
10.
Say that again?
10.
10, yeah.
Yeah.
So what type of thing is 10?
Say
it's obvious. Like, just tell
it's
me
a
what you're
number.
thinking. It's a number. What type
Yeah.
of number?
A real number?
It's a real number. So, like, I mean, it's not obvious from this formula. I didn't actually tell you that this was a function from the real numbers, but that's usually what we're going to do. Is we're going to usually always think of our functions from real numbers to real numbers. That means they can be decimals. That means they can be irrational or negative. Because some functions might only take in integers or whole numbers or something. But for us, there'll always be all real numbers or some smaller part of it. So one thing we're going to be doing quite often is you have to be able to graph a function. And I always have trouble drawing straight lines in this. And you've probably know that the graph of this looks like an upward facing parabola, right? And what's the key thing you have to know about graphs? So if I pick the number, say 2 over here, what xy point is this? What do you guys think? What's its x coordinate?
2, 4.
Yeah, and so how did we get the 4?
2 squared is 4.
Right, so this is really f of 2, which is 2 squared, right, which is 4. Right, so the important point here is every point on a graph if it's actually on the graph of the function is of the form some number and then the output at that number, right? It's the x and the y. Okay. And if you plot all those points for all the inputs, you get the graph. So that's really what this graph is, right? And so then what's the domain and range here? So from what we said before, we can plug in any number really. So the domain is all real numbers. And the way we're going to typically do that in this class is we're going to stick to interval notation. So we would write that like this. It's any number between minus infinity and plus infinity. And we use round brackets because the infinities aren't really actual numbers, so we don't include them. Right? So it could be any number. It could be minus 10 billion. It could be pi times 3. But it's we can plug anything in the real numbers. And then what about the range? So the range, remember, is all the things that can come out, right? So on the graph, if you plug in 2 and follow it up, then the y value at that value is the output, right? So this is the input, this is the output, right? So now think about, as I move this 2 to the left or to the right, you know, if I go over here, I'll get different outputs, right? But what region of the y-axis will it cover? Well, the only outputs that will ever come out are this part here, right? They will land here. Okay, so that tells me that the only outputs that could ever come here are, well, I can get as big as I want, so we can go off to infinity, but can it go as small as it wants? Well, no, because there's no way to get negative numbers. Like this part down here never gets landed on. And the smallest thing that does happen is 0. Okay, does that sort of make sense to people? So, you know, one way to think of the range is it's sort of like if you were to shine a light from the side, like what's the shadow onto the y-axis? What part of it does it actually hit, right? And you can do this with all sorts of functions. Maybe let's do one more of these. So let's look at what's one's a little more interesting. Let's do a trig function. So sine of x. So if you don't remember your graphs of your sine functions or your cosines, it's a good thing to brush up on. So what's sine of 0? Anybody? What's sine of 0?
Zero.
Correct. Good, thank you. And I don't care if you're wrong either, but you are correct. So remember, in the unit circle, if I pick an angle, theta, then the x, or the coordinate there is the x coordinate is the cosine of that angle, and the y coordinate is sine theta, right? And so for an angle of 0, the x coordinate is 1, the y coordinate is 0, so sine ends up being 0. You know, so that would at least like get you one point on the graph. If you wanted to do the whole thing, you would see that it goes something like this. My graphs aren't going to be perfect, so this would be like pi. This would be 2 pi, So it'd be negative pi. And what's the maximum output here? What's the output here? Anybody know? What's the biggest that can ever come out of a sine?
1.
Correct, 1. So now if we, and the smallest you'll see is negative 1. So this lets us write down the domain and range pretty easily. So the domain of sine is, well, I can plug any angle in. I can go around the circle as many times as I want in either direction. So it's, again, everything. But what's the range here? What's the smallest number that can be output by a sine? Well, we just said it was negative 1, right? And we include negative 1 because it's included as an output, right? I could get it from going over here. You know, that's what, like 3 pi over 2? If you followed that down. The biggest would come up from having one of these at 1. You know, you'll notice that they happen many times, but all it needs to happen is at least once. So you'd see that the domain and range are these things. And does everybody remember, like, what this notation means? What does square bracket minus 1 to 1 mean?
That it includes the 1,
That what includes the 1?
the range.
Yeah, so what this really means is it's all numbers between minus 1 and 1, including minus 1 and 1. So yeah, the square means included. But really, the interval notation means it's all numbers between those numbers are also included. Okay, and if you use a round bracket, it means that that number isn't included on the end. Okay, good. So that's just some very basics. Let's jump into something a little more interesting. Let's think about piecewise functions, because those are things that usually people have more trouble with. So kind of the most simple example of a piecewise function is absolute value of x. So let's make it into a function. So now absolute value of x, what does absolute value do to a number? It can do one of two things, right? So whenever you have a situation where a function does something in one case and something in another case, that's where a piecewise function comes from. So if I throw a positive number into an absolute value, what does it do to it? So if I threw, what's the absolute value of 3?
3.
3. So it didn't do anything to it, right? So if I input a positive number, or 0, it just gives me back what I started with, which is just x. So if I input x, it gives me x back. What if I plug in a negative number? Well, what's the absolute value of negative 3? Well, that would be 3. So if I plug in negative 3, and I want to get 3 out, and you have to think of negative 3 as being x, so I have to take the negative of that number, because the negative of the negative 3 is positive 3, right? So this is basically the definition of absolute value of x. So whenever you think about it, you should, in some sense, be thinking of this. Okay, now how do we graph things like this? Well, what you do is you look at the cases first. So the two cases here are these two parts, right? So one part is when x is 0 or bigger. And remember, when you're drawing a graph, the inputs are always along the horizontal axis, right? So like this first case corresponds to all these inputs here, right? And so basically what we do is we say, well, I know what the graph of x looks like, because in this case, we have x. And I know x looks like this, right? It's just a straight line, y equals x. But in the piecewise function, it says only do that if x is positive or 0. So what I can do is I can erase all the part that's for negative x's. And so this is kind of what happens over the positive part. And then if you think about when x is negative, it says I should be doing negative x, and negative x looks like this. Right? It's a straight line in the other direction. But then I only want the part over, I only want to do that when x is negative, so I only use it over the part where, x is negative over here. Okay. So you kind of have two parts of the graph that you kind of put together separately, right? And so this is the graph of absolute value x. It's like this V-looking thing. Okay. Okay, so let's have you do a little math for now. I'm going to write down a couple problems, and then we'll go through them together. So go ahead and take a few minutes and try these. Just to make sure we're all on the same page, we're just trying to make sure everybody has the very basics today. So I'm giving you a function here, and I want you to compute three things: f of 3, f of 1 plus h, where h is just a variable, and let's say compute. What is f of x squared? Okay, so that'll be problem 1, and then the second one is to graph another piecewise function. Alrighty, so take like 2 or 3 minutes and see if you can write these out yourselves, and then we'll go through them. See if you have any questions. Alrighty, so for problem 1, what you should have gotten is you should have gotten, right, so when we take f of 3, it basically means put 3 wherever you saw x. So you should get 1 plus 3 squared over 3. And then whatever that ends up being, let's see, that's 10 over 3, 10/3. Same thing for all the rest of these. It's just a matter of these ones involve variables. So instead of replacing x with 3, now I replace x with 1 plus h. So x was squared, so 1 plus h has to be now squared over 1 plus h. And we're just going to leave it like that. We're not going to waste our time simplifying. A lot of times I'm not going to require you to simplify things, as long as you can get it to a reasonable format. And the last one would be, now I have to replace x with x squared, so it'll be x squared, which is then squared again over x squared. Which if you wanted to, you could simplify to 1 times x to the 4th, because those x wanted to multiply. So you get something like that. Okay, so any questions about the first one? No, okay, so let's look at the second one. This might have been a little more difficult. Let's see if we can put in a little graph here. Okay, so this piecewise function has two conditions, right? Or two cases, really. One when x is strictly bigger than -1. So let's find out. Let's say -1 is over here somewhere. So if x is strictly bigger than -1, we have this square root thing going on. So we first might just say, well, let's forget about everything. What does the graph of square root of x plus 1 look like? And if you remember, well, you know, the square root of x looks something like this, right? So if I replace x with x plus 1, you might remember that that shifts it to the left by 1. So instead of starting at 0, it's going to start at -1. So it does something like this. And that's something we'll talk a little bit about tomorrow, or rather the videos you watch will talk about. And luckily for us, that's exactly over the case we wanted, right? This was all for numbers bigger than -1. For things less than -1, and this one's included on the end because of the equal sign down here. Otherwise, we would use an open circle there. Now we have the function 2x plus 2. Right, so 2x plus 2, what does that look like? Well, it's a straight line, right? Because it's like y equals mx plus b. And let's be a little careful about it. Like, what's this point here? This is the square root of 1, which is just 1. Whereas the y-intercept of 2x plus 2 is up here at 2 somewhere, right? So it might be something like this. 2x plus 2 might look something like this. But we don't want the whole function. We only want the part of the function that lies over the things that are smaller than -1. So we've got to erase a bunch of this, right? So we erase a lot of this, and what do we end up with? We only want the part that goes up till -1. Right, and then we use an open circle here because, you know, on this condition here, there was a strict inequality, so it didn't actually apply to -1, so that point at -1 isn't actually included. Okay, so you'd get something that looks roughly like this, right? You have these kind of two pieces that are put together. Does that kind of look like what people were getting? Any questions about that one? Okay, so for the last like 15, 20 minutes here, we're going to try something else. So we're going to try this thing called breakout rooms, which is basically, I'm going to put you in groups so you can work together on a few problems. So first things first, I would like you to copy down these problems. There's just 2 of them. So first one is, let's make them numbers, to sketch the graph of this function. Number 2 is to sketch this piecewise function where it's absolute value of x if absolute value of x is less than 1, and it's 1 if absolute value of x is bigger than 1. Okay, so just these two problems. Okay, so I'll give you a minute to write that down. Okay. So basically, I'm going to split you into groups, and then there's something I'd like you to try. I'm not 100% sure how well it will work, but let me show you something. There, you should be able to see my screen. So I've set up something which are called Google Jamboards, so if you go to our Canvas page, it's basically a quick way for you to show us our work. So one thing I'd like you to try out is if you click this link, there's going to be, so basically there'll be 6 groups of you. Each one I've set up one of these things called a Google Jamboard. So say you end up in group 1, and you should be able to tell as I'm putting you into the rooms which one you're not, which one you're in. It's probably the least effective way to do this, but whatever. We'll figure it out later. So you should end up somewhere here. And basically the idea is if you do this on your phone, not on your computer, what you can do is you can, there's like an insert. If you do this on your phone, it'll ask you to download the Google Jamboard app. If you do that, then there's just a button where you can take a picture of your work and just insert it directly here. And then either me or the TA can see your work and write on it and give you feedback. So did that make any sense? So the idea is you go to Canvas on your phone, click that link for your group, then you can take a picture of your work and just insert it in there directly. And the other people in your group can see it, I can see it, or my TA can see it, and we can write on it and give you feedback. Okay, so I'm going to break you into groups. I want you guys to talk in your groups about those 2 problems and maybe try the Google Jamboard thing if you want. Okay, so let's